Hello everyone and welcome to St. Andrew's Institute of Technology and Management, Gurgaon, Delhi NCR. St. Andrew's Institute of Technology and Management is the best college in entire northern India and the fastest college upcoming in the country. It has best infrastructures and provides very high quality education. It provides 100% job placement and assistance. There are a variety of courses to choose from, like BTech, BBA, PCA, and they are soon starting up with MBA, Architecture, and Law. This is one of the finest college that you can get yourself admitted to. We study here subject Principles of Software Engineering. The code is CSE 302F. This is a CSE 6 semester subject. And the topic that I shall be taking over here is the art of debugging, the debugging process, debugging approaches, software re-engineering, reverse re-engineering, restructuring, and forward engineering. I, Shalini from CSE department, shall be taking you forward in the video. The art of debugging. See, debugging is the process of fixing a bug in the software. In other words, it refers to identifying, analyzing, and removing errors. So, what you do, you identify. Also, bug is basically something which is the error that has already occurred in the system and you want to remove it. So, what is the process? First, you will identify like what has caused an error, and then you will try to analyze like why it has caused this error, what mistake is it, and then you try to remove the error, like how it can be removed. So it has three processes: identifying, releasing, and removing. This activity begins after software fails to execute properly and conducts by solving the problem and successfully testing the software, right? So this is, I was talking about that first there will be an error, then only you can debug it, right? So debugging is the process of finding and resolving defects or problem within a computer program that prevent correct operation of current software or a system. That's a formal definition. If it comes in 1 mark, you can write this. Now we come to the debugging process. So what is the debugging process? What are the steps involved? Okay, so we discussed in the previous page also. So first, problem identification and report preparation. So what you will do, you will identify the problem, like what has caused the problem, and you will report the preparation of that, right? You will generate a report, right? So you'll prepare based on your findings, that you whatever you have identified as the cause of error, you'll try to make a report, like document it. Then you assign the report to the software engineer to verify that it is genuine, right? So what you do, you give it to the engineer and say that this is something which I have found out and this is the genuine faults in the system, right? Then defect analysis is done using modeling, documentation, finding, and testing candidate flaws, etc. So you do all the stuff, right? Defect analysis by you try to model it, try to document it, then you find and test what are the candidate flows that have taken. Then comes defect resolution by making required changes to the system, and in the end it is validation of corrections. So whatever like that has happened, you'll try to validate your corrections, that all these my corrections that I have done in the system are actually valid, and you actually make the system work, right? So there are various approaches into debugging a system. So what is the first one? That is brute force method. So this is the foremost common technique of debugging, right? However, this is less economical. Why? Because brute force means you will apply each and every. The name is suggesting like what is brute force, right? So during this approach, the program is loaded with print statements to print the intermediate values with the hope that a number of written values can facilitate to spot the statement in error. So you will just see like what are the, you load all the print statements, and then you will see the intermittent values and see like how you facilitate those the error in the statement, right? So this becomes a lot systematic with the utilization of symbolic programs, that is source code debuggers. So these are kind of softwares that are as a result of values of various variables, and they are simply checked in breakpoints. Breakpoint like there and where the system is kind of break. So that's a breakpoint, and you wash them and then you set the values of the variable effortlessly. So this is actually done in the brute force, right? Then it comes backtracking. So see, as the name suggests, what we mean by backtracking do. So this is during this approach, starting from the statement at which an error system has been discovered, the source code is derived backward till the error is discovered, right? So where the system has failed and what are the systems, so you work at the symptom of it and then you track back to the error, like what is the source of it, right? So from symptom you're moving to the source. This is what you're doing. Because of the variety of supply lines to be derived back will increase, the quantity of potential backward method will increase and should become unmanageably large, so limiting the utilization of this approach. So what you do, the quantity of potential backward method will increase. So like if you're using two methods, say as an example we can say into the first, so when you move to the next step then again 2, so this is like 2 2, so this is how it happens. 2 becomes 4 and then 4 becomes 5. So this is how your actual quantity of the effort that you're putting in is actually increasing as you backtrack. Cause elimination. Okay, so you list the causes that have presumably, you first make a list like to what might have contributed to the error, right? And then you conduct a test to eliminate each and every risk like that may cause it, right? This happens in a cause and elimination method. So a connected technique of identifying of the error from the error system is that the package fault tree analysis you do. This might be the cause, this might be the cause. And program slicing is analogous to backtracking. So here the search house is reduced by process slices. A slice of a program for a specific variable at a particular statement is that the set of supply lines preceding the statement which will influence the worth of that variable, right? So you slice the program out for a particular variable and then you see that what are the supply lines that preceding this statement and how they're influencing that variable. So you are kind of divided it based upon the variables that are there. Then you come to software reengineering. Software reengineering is the examination and alteration of a system to reconstitute it in a new form. So what you do, you are restructuring the software. So it says reengineering. And the principle of reengineering when applied to software development is called software reengineering, right? So it affects positively at software cost, quality, service to the customer, and speed of delivery. So in software engineering, we are improving the software to make it more effective and efficient, right? And what are the cost? That is the quality of the software to be engineered. First you look what is the quality actually, the one that you are being in re-engineering. Then you look at the support tools that are available for the engineering, right? Then the extent of data that is to be converted, right? And the availability of expert staff, which is very very true, like you already need it, and only these will decide like what kind of a budget your this will fall into, right? So you do an inventory analysis, then you do document restructuring, then reverse engineering, code restructuring, data reconstruction, and forward engineering. So this has a number of activity. With the first one is inventory. See, every organization have an inventory of all the application. So inventory can be nothing more than a spreadsheet model containing information that provides a detailed description of every active application. So you are actually making this information a very very detailed describing each and every action application. So by sorting this information according to business criticality, longevity, the current maintainability, and other local important criteria, the candidates for reengineering appear, right? and the resource can then be allocated to the candidate application for the re-engineering. So this is how it is happening. So you first do according to the longevity, you see how it is being done, then you try to see what's the current maintainability cost and what are the other costs that are involved, right? And then you allocate it as per the work that you need to do. Then you have document restructuring. So see, documentation of a system either happens how it operates or how to use it. So how it is operating or how we are using it. So that is how the documentation is done, and it must be updated. So it may be necessary to fully document an application. The system is business critical and must be fully re-documented. So you, if any changes or bug fixes had taken place, so you actually need to retract and see like what are the changes that you can make into your document file, which is very very important. Okay, next we come to the reverse engineering. So what in here you do is that, so this is a process of design recovery. Reverse engineering tools extract data, architectural and procedural design information from an existing program. What you do, you extract the data, you extract the architectural and procedural design information from an existing program, and that is how you do the process of reverse engineering. Then you have code reconstructing. So to accomplish code reconstructing, the source code is analyzed using a reconstructing tool. The violations of structured programming construct are noted and code is then reconstructed. The resultant restructured code is reviewed and tested to ensure that no anomalies have been introduced. What is data restructuring? This begins with the reverse engineering activity. The current data architecture is dissected and necessary data models are defined. The data objects and attributes are identified and existing data structures are reviewed for quality. Okay, then the last comes the forward and restructuring. So what do you do in a forward engineering? So this is called renovation or reclamation, not only for recover design information for existing software, but this uses the information to alter or reconstitute the existing system in an effort to improve its overall quality. So that is forward, means you want to take it a step further. That's why the name forward comes. And restructuring, as the name suggests, so this will be architectural recommendation and best practices for regenerating in client specified technology, right? And the high level effort estimated of re-engineering for client required technology is actually restructuring. So you are constructing the entire according to the client needs, you are doing it, right? So forward will be basically renovation. Okay, then we have done almost, but there still comes a question, the difference between forward and reverse engineering. So you actually need to be aware and write a couple of differences between them. See, in forward, the application are developed with the given requirement, where in reverse, these work backward, and the information is collected from given application. So that's forward means from the requirement, and reverse means from the applications. And this is high proficiency skill. Forward, but the reverse is low proficiency, because you want to retrack back and see like how it happened. You don't have any knowledge. That's why it is low proficiency. And forward takes more time to develop an application, while reverse takes less time to develop an application. The nature of forward engineering is perspective. The nature of reverse engineering, backward engineering, is adaptive. In forward engineering, production is started with given requirements, and in reverse, it is started by existing product. So product is the starting point, origin of this. The example of forward engineering are construction of electronic kit, construction of DC motor, and the example of backward are research on instrumentation, etc. So that these questions are there, like what is debugging, the process of debugging, the various debugging approaches. Now what is software engineering, what is reverse engineering, what is restructuring, what is forward engineering, the difference between reverse and forward. So you have knowledge as to exactly what to write in the paper if it comes the difference between the reverse and forward. So that's all in today's video. Thank you, have a great day.